Look at number 129. We're going to prove if HM, so line segment HM, is congruent to ML. So we do want to use the distance formula for it because that's the instructions. We could also use the midpoint, but we're not going to go that down that road. So let's first make this our HM section. H is at -1, 3. M is at 1, 7. Just do a little split so I can keep it organized. And then here will be ML. M is at 1, 7. And L is at 3, 3. Alright. So I'm going to write the distance formula up here so we know what it looks like. Distance is equal to the square root, the difference between the x's squared, plus the difference between the y's squared. So x2 minus x1 squared plus y2 minus y1 squared. Next thing we have right here is we're going to label our subscripts. x1, y1, x2, y2. Plug these into this formula. D is equal to the square root of 1 minus -1 squared plus 7 minus 3 squared, which is equal to the square root of 1 plus 1, which would give us 2 squared, plus 7 minus 3 would be 4, 4 squared, which we get square root of 4 plus 16, so we get square root 20. So we get square root 20 right here. Let's leave our answer like that. We don't even need to simplify it, because you could pull out a 2, but why do that when we're just comparing to see if it's the same distance? If it is, it's going to give us square root 20. Same thing, label our subscripts, x1, y1, x2, y2. D is equal to the square root of x2, which is going to be 3 minus 1 squared plus 3 minus 7 squared, which is equal to the distance of 2 squared plus -4 squared, which we get square root of 4 plus 16, which is equal to square root 20. Square root 20 is the same as square root 20, so therefore HM is congruent to ML.